Hello friends, welcome to my tutorial of limits. It's part 3. In part 1 we had done limits of a polynomial function where we had simply substituted limits. For finding limits we had substituted x with a, and in part 2 we had done questions of the form limit f of x upon g of x, where we had done 3 cases. Case 1 was simple, in which denominator was not 0. Then in case 2 we had studied where denominator was 0, and in case 3 we had done questions on 0 by 0 form. So in part 3 we are going to study this theorem on limits, which is if limit x tends to a, x to the power n minus x to the power n minus a to the power n upon x minus a equals to n a to the power n minus 1. So basically now we have to learn this formula. So if limit x tends to a, and we have a question of this form, x to the power n minus a to the power n upon x minus a, then the answer will be n a to the power of n minus 1. For easy learning, we have this a to the power n. Now we turn this n on the left side, n, and decrease the power of a to n minus 1. So basically this is the formula. Okay, so now first we'll prove it. So for proving it, there is another formula. See, we have to prove this. So we'll take the numerator. There is a formula for a numerator, x to the power n minus a to the power n. Its formula is x minus a into x to the power of n minus 1 plus x to the power n minus 2 into a plus x to the power of n minus 3 into a square plus x to the power n minus 4 into a cube up to x to the power 0 a to the power n minus 1. Now how you will remember it? See, this formula is x to the power of n. Now you are taking this x minus a common. So maximum the power of x inside can be x to the power of n minus 1, because it has to be equal to x to the power of n. So you are already taking 1x out. So inside we will have with x to the power of n minus 1. Now this is the highest power which can be inside this. So x to the power of n minus 1 and then a to the power of 0. Then we'll go on decreasing the power of x and increasing the power of a. So x to the power of n minus 2, a to the power of 1. Then x to the power of n minus 3, a to the power of 2. Then x to the power of n minus 4, a cube. Simply we'll go on, and the last will be x to the power of 0 and a to the power of n minus 1. So like the first term was x to the power of n minus 1, last term is a to the power of n minus 1. Here it was a to the power of 0, last term is x to the power of 0. Alright. So basically this is the formula, and you will have to use this formula for proving this above formula. So we have this limit x tends to a, x power of n minus a to the power of n upon x minus a. Now we'll divide this formula with x minus a. So this x minus a will cancel out, and we'll have we'll have this. So x to the power of n minus a to the power of n upon x minus a equals to this, using the above formula again. And now we'll put limits on both the sides. So limit x tends to a, x to the power n minus a to the power of n upon x minus a equals to limit x tends to a, x to the power of n minus 1. So basically we are putting limits on both the sides. Now see this, x to the power of n minus 1. So for finding its limit, we simply put x equals to a. So a to the power of n minus 1 plus a to the power of n minus 2 into a plus a to the power of n minus 3 into a square plus a to the power of a into a to the power of n minus 2 plus a to the power of n minus 1 equals to a to the power of, now what is this, a to the power of n minus 1 plus a to the power of n minus 2 into a. So this is again n minus 1. Now a to the power of n minus 3 into a square is again a to the power of n minus 3 plus 2, that is a to the power of n minus 1. Now we'll continue this up to a to the power of 1 into a to the power of n minus 2 is again a into a to the power of n minus 2 plus 1, that is n minus 1. So a to the power of n minus 1. Again last term is also a to the power of n minus 1. So this is a to the power of n minus 1. How many times? This we have to find out. This is how many times. So finding it that this is written how many times, we'll just go through this above expression. See, here we had a to the power of 0, and in last term we have a to the power of n minus 1. So basically from a to the power of 0 up to a to the power of n minus 1, these are how many terms we have to find out. So if suppose a was a to the power of 0 and this was a to the power of 1, suppose, तो कितने then the number of terms will be 2. So basically what is this, 1 minus 0 plus 1, right? If we had terms a to the power 0, a to the power 1, a to the power 2, a to the power 3, then how many terms would it have been? 4. These are 4 terms. How can we calculate it? 3 minus 0 plus 1. So basically 4 terms. Similarly, if we have terms from a to the power 0, a to the power 1, a to the power 2 up to a to the power n minus 1. And these are how many terms? n minus 1 minus 0 plus 1. So basically n terms. So here we have a to the power of n minus 1 up to n terms. So that is n times a to the power n minus 1. So n into a to the power n minus 1. So I hope you get this formula. So finally the formula is limit x tends to a, x to the power n minus a to the power n upon x minus a equals to n को इधर ले आओ, n into a to the power of n minus 1. So we'll do some questions on it. So first simple question is this. Now limit x tends to 1, x to the power 15 minus 1 upon x minus 1. So we'll break it into the form of this. Limit x tends to a, x to the power n minus a to the power n upon x minus a equals to n a to the power n minus 1. So we'll write here x to the power n minus a to the power n upon x minus a. So n, which is 15, a, which is 1, to the power n minus 1. 15 minus 1. So answer is 15. Alright. You can have a quick look at it again. You can pause this video and try it yourself. Okay. So now let's move on to another question. So next question is limit x to the power of 15 minus 1 upon x to the power 10 minus 1. So again we'll try to break it so that we can use this formula x to the power n minus a to the power n upon x minus a. So x to the power n minus a to the power n, x to the power 15 minus 1 to the power 15 upon x minus a, that is x minus 1, into so suppose if we are using this x to the power x minus 1 here, if we multiply x minus 1 and again x to the power 10 minus 1 to the power 10, and this expression equals to this expression, simply we are multiplying both numerator and denominator with x minus 1. So this remains the same. Now this term is of this form, x to the power n minus e to the power n upon x minus a, but this term is inverted, so we'll divide. We'll put a sign of divide and this thing will get inverted. So limit x tends to 1, x power 15 minus 1 power 15 upon x minus 1 divided by x to the power 10 minus 1 to the power 10 upon x minus 1. So simply equals to n, that is 15, into a, that is 1, to the power of n minus 1, that is 15 minus 1. Similarly, x to the power n minus a to the power n upon x minus a equals to n, that is 10, into a, that is 1, to the power of n minus 1. So this is 15 divided by 10, that is 1.5. So 1.5 or 3 by 2 is the answer. You can again, if you want to try it yourself, then you can pause this video and complete this question by yourself. Okay. So this was the question. Right. Now let's try on another example. So next question is limit x tends to 0 under root of 1 plus x minus 1 upon x. Now we'll again try to break it in the form of this, x to the power n minus a to the power n upon x minus a. So how can we do this? See, somehow we have to convert this into x. So basically under root is of power half. If we have written, see, under root 16, we can also write 16 to the power of half. So basically x to the power of half this is. So if somehow if 1 plus x, we can treat it as another variable y. So now if we try to put 1 plus x equals to y, then we'll convert this expression in terms of y. So if 1 plus x tends to 0, x tends to 0. So now x tends to 0, then y will tend to 1. Why? Because we will substitute x with 0, then y will tend to 1. So limit x tends to 0 will be limit y tends to 1. And now this is under root 1 plus x. 1 plus x is y, so it's y to the power of half minus 1 upon x. X is y minus 1. So this form is broken into this form. So basically we have successfully broken it into the form of limit x tends to a, x ki power n minus a to the power n upon x minus a. Alright, equals to n half into a 1 to the power of n minus 1, n is half minus 1 equals to half. 1 to the power of anything is 1 only, so it's half. So the answer is half. Alright. So similarly we have another example. So basically the question is limit x tends to a, x plus 3 to the power of 3 by 2 minus a plus 3 to the power of 3 by 2 upon x minus a. Now again we want to break it into x to the power of n minus a to the power of n upon x minus a. So x to the power of n, right? So we will convert x plus 3 into another variable y minus a to the power of n. So we will convert this a plus 3 into another constant, say b. So, and if x tends to a, then y will tends to substitute x with a, y will tend to a plus 3. Alright, and a plus 3 is b. So we will try to break this whole expression in terms of y and b. So limit x tends to a, x plus 3, this was our original question. Alright, and limit x tends to a has been converted into limit y tends to b. Alright, y tends to b, and x plus 3 is written as y and a plus 3 is written as b. So this is y to the power of 3 by 2 minus b to the power of 3 by 2. Now x is y minus 3, right? From here x is y minus 3 and a is b minus 3. Alright, so this will be broken into y minus 3 minus b plus 3, so it's y minus b. So we have broken it into the form of x to the power n minus a to the power n upon x minus a, and x tends to a, limit x tends to a. So again we can simply apply this formula, n into a to the power of n minus 1. So n here is 3 by 2 into a is b to the power of n 3 by 2 minus 1. So it's 3 by 2, b to the power of 3 by 2 minus 1 is 3 minus 2 by 2, that is 1 by 2. So now again our original question was in terms of a, so we'll have to break it, we have to break b in terms of a. So b is equals to a plus 3. So this is our final answer. So guys, I'll suggest that you practice these 3 questions, rather these 4 questions yourself. Alright, and if you have any doubts, then try to repeat this video. And if you have any suggestions or queries, you can post it, and you can subscribe to my channel for more videos. So thank you, bye, and keep learning.